Okay, we are now on still section 5.3, and we are now looking at the factoring portion of the section. Whew. Okay, they have listed here as 4. I've kind of condensed these two into the same one. You do not have to write this down. We have greatest common factor, otherwise I call it greatest common monomial, difference of squares, and then the rest I just call factoring trinomials. Why do I do that? Because this is just a special technique of the other one. You'll get it if I just teach you one of the two. Oh, lovely. All right, here we go. Examples 1 through 4. Here we go. Greatest common factor. So you're going to look at your terms. What do 5x squared and 120 share in common? Well, I think they both have a 5 that goes into both numbers. And then I put the 5, what I call it, out front. And 5 times what gives you 5x squared? X squared. 5 times what gives you 120? I believe it goes in there 24 times. Okay? So you've taken a 5, they both share 5, and you pulled it out of both of the terms in the binomial. And that's it. Some of you might think you can factor this down somewhere, but you cannot. All right, what do 2x cubed and 30x share in common? Well, they both have an even number, so 2 is going to come out of both, and they both have x's. We've done this before, so I don't have to go into as much detail as Algebra 1. So hopefully this is review. If not, make sure you're asking questions in class. So 2x is pulled out of both terms. 2x times what gives you 2x cubed? Well, you would have to take it times x squared. Why is that? 2 times, there's technically a 1 there, is 2. X times x squared is x cubed. All right, minus 2 times 15 gives you the 30, and I already have 2x times 15 gives me 30x. Done. There's no more factoring to be done with that one. Okay, 16, 40, and 28. They're all even, but if you don't take out the greatest common factor, I don't count it right. You need to find the largest factor that goes into all 4 of those. 2 is a factor, it's not the largest one. 4 goes into all 3 terms. So 4 times 4 gives you 16, along with the x squared. 4 times 10 gives you 40. And 4 times 7 gives you 28. All right? And that does not factor anymore, I don't believe. We're just going to stop it right there, even if it does. All right, what's a common factor here? I believe 3 goes into all of those terms. Uh-oh, this is supposed to be an x squared. My bad. Pretend that says x squared. All right, now they all have an x that they share. So I'm going to take out the 3 and the x. 3x times x squared gives you 3x cubed. Then we have a minus sign. 3x times 4x gives you negative 12x squared. And 3x times 2 gives you 6x. And we're calling that one done. Okay, that's your very, very fast review over greatest common factoring. All right, examples 5 through 8. This is difference of squares. Always check for a common factor first. And if not, then I sing this little doohickey song, common monomial factor, because then it will remind you and you'll be so sick of me singing that. All right, because you have to pull it out. Is there a common factor? No. So you put down 2 kinds of parentheses. What times what? This is reverse FOIL, gives you x squared. Well, x and x. What times what gives you 16? 4 and 4. How do I get a negative sign when I multiply? One's positive, one's negative. It does not matter which one is which. On this first one, I'm going to FOIL it out so you can kind of see what happens here. You get x squared minus 4x plus 4x minus 16. These are gone. Left with x squared minus 16, which matches over here. So this is the correct factoring. All right, let's go on. Oh, is there a common factor? You have to force yourself to check. Is there a common factor between 4x squared and 36? I believe so. It's 4. Okay, so now I have x squared minus 9. But here's the kicker. X squared minus 9 is a difference of squares. This is the difference, meaning subtraction. These are both square numbers. So I keep the 4. It does not disappear, and I write out 2 sets of parentheses. What times what gives me x squared? X and x. What times what gives me 9? 3 and 3. So I have a plus 3, I have a minus 3. If I want to check my work, I would go ahead and FOIL this part, take it back times 4, and I would get this. You're going to believe me because I'm calling her done. All right? Is there a common factor? Common monomial factor. There's my x. And that's all they share, is an x. So I actually have x squared minus 100 in parentheses. But this is a difference of square numbers. So I have x, because I don't want to forget it, and I put down my two parentheses. X and x. What's the root? The square root of 100, it's 10. What do I do with my signs? I need a negative, so I make sure one's plus and one's minus. Once again, it doesn't matter which one comes first. Double check. I think I'm done factoring this one. If I wanted to check my work, I would, but I'm telling you, we're done. On to this one, 5x squared minus 125. What's a common factor? 5. Now I've got x squared minus 25. Okay, this is a difference of square numbers. So 5, two sets of parentheses. I've got an x and an x, and then I have 25. So I've got 5 and a 5 here, plus, minus. And that is the correct factoring. If it said x squared plus 25, it would actually be not well, I don't want to say not factorable. It just wouldn't factor any further than this, because that would not be a difference of squares then. It would be a sum of squares, and we do not have a factoring process for that. Examples 9 through 12. This is the trinomial factoring. Still, check for a common factor. Is there something that goes into 9, 12, and 4? No. So put down two sets of parentheses. What times what? This is a special case. These are both perfect squares. If that's the case, we're going to shoot for what times what gives you 9x squared? Go for 3x first. Okay? Look at your last terms. 4. Well, I got 2 and 2. Okay? This sign is negative, but this sign is positive. So I am going to need to have either plus 2 and plus 2, but then I would never get a negative out of it, or I have to have negative 2 and negative 2. All right, this I'm not going to let you say good enough. You need to check. 3x times 3x is 9x squared. Negative 6x, negative 6x, positive 4. So this is actually 9x squared minus 12x plus 4. Matches here, but this is your answer. Normally we do work to get to the answer. Here you're going to do the work after the answer. All right, 63, x squared. This is not a perfect square, is it? So I know I've got x and x. Oh, but what am I going to multiply? There's what goes into 63. I'm going to make a list. 1 is 63. If you had me for Algebra 1, do you remember the factoring project? Yeah, you had to make a list. 2 does not go into that. 3 does. 3 goes in there 21 times. 4 does not go into 63. These are factors of 63, by the way. 5 does not go into 63. 6 does not. 7 does. 7 times 9. Now, here's the other thing I kind of looked at, and this only works if your coefficient here is 1. And now it looks like 211. Let me going to do that. Okay, my coefficient is 1. This is the only time I get away with this. 7 and 9 happen to add up to 16. Or if this was a 2, maybe I'd be working with 9 and 7. If this middle number was a 24, I'd want to work with 3 and 21. Or if the middle number was 18, it's 21 minus 3. 60. If my middle number was like a 64, then I might want to work with 1 and 63. So let me go with the 7 and the 9. Everything's positive here. Everything's positive here. How do I check? X squared plus 9x plus 7x plus 63 is the same as x squared plus 16x plus 63. Ooh, that matches. How lovely is that? Done. I mean, we could spend, hours and hours just factoring and getting really good at it, but on this examples here, I'm just going to give you some 4 basics, and we'll learn the rest hopefully in class. All right, common factor. Ooh, yeah, there is. 2 goes into all 3 of those. So I have 2 times 3x squared plus 5x plus 2. And now this, I should check to see if it factors. That means I keep the 2, I put down 2 sets of parentheses. What times what gives me 3x squared? The only option is 3x and x. What 2 numbers multiply to give me 2? Well, 1 and 2. So let's just go ahead and say 1 and 2. Everything's positive here, so I'm going to put everything positive here. Double check. The only part I'm going to double check though is just the parentheses. So I have 3x squared plus 3x plus 2x plus 2. 3x squared plus 5x plus 2. Does that seem to work? That does. So with that said, this is the correct factoring. If you had gone the other way, 1 and 2, you would have ended up with a 6x and a 1x. It just wouldn't have worked out. And if that happens, I meant to do it the wrong way first, then you will have to switch your values. Okay, let's go on to the next one here. This one, I want to put it in the form that we have all of our quadratics in. So I'm going to start, I like to lead positive, so I'm going to subtract 10x, and I'm going to add 8. All right, we can't do factoring with this equal sign stuck in the middle there. Okay, is there a common factor? I do not see a common factor. So now I put down my 2 sets of parentheses. I look at 3x squared. So my only options, once again, are 3x and x. Let's see, what multiplies to give me 8? Well, I have lots of options. 1 and 8. Lots of options. 1 and 8, 2 and 4. The only thing is order is going to matter here. It could be 1 and 8. It could be 8 and 1. It could be 4 and 2. All right? I think I'm going to start, and this is my general, my tip, is start with the numbers that are closer together. Like here, even 7 and 9 are the closer numbers together than any of these. So start there, unless your middle number is outlandish, like 64 in this case. So I'm going to start with 2 and 4, and if that doesn't work, then I'll try 4 and 2. And if that doesn't work, then I'll try 8 and 1, and then 1 and 8. So let me go with 4 and 2. All right, here we go. I need a positive 8, but a negative 10. That means both of my signs will have to be negative over here. If I FOIL, I get 3x squared. I get negative 6x. I get negative 4x. And I get positive 8. So now I have 3x squared minus 10x plus 8. And that does match with this. This is the correct factoring. Once again, why did I do it right the first time? I actually kind of want to give examples where they're wrong. But I'm sure we'll have plenty of opportunity in class. All right, and that ends our lesson.